In this video, we're going to look at how to solve by factoring or with the quadratic formula. A quick vocabulary review that can be helpful when solving equations is that another name for solutions can be derived from looking at a graph. So if you look, solutions we learned is where the graph touches the x-axis. So we can also call solutions x-intercept. So for the problem to the right, my solutions would be -2 and 4. But if you look, what those solutions have in common is that the y value is also 0. So another word we often tend to use for solutions is 0. Since we also call solutions zeros, that should give you a big hint that to solve any equation, we must set the equation equal to 0. Then, if you can, factor it and set each factor equal to 0, and then solve each factor for the given variable. So let's consider this first example. I could set this equation equal to 0 by moving all these three terms to the right side or moving the 2b to the left side. Either way works, but since 2b is just one term, I'm going to move that one by subtracting 2b to both sides and combining it with this other term. And that gives me -b to the third plus 4b squared minus 12b equals to 0. Now, since my first lead coefficient is negative, I'm going to factor out a negative, but I also have a b for my greatest common factor, so I'm going to factor out a -b, and then I'm left over with b to the second power plus 4b minus 12 equals to 0, and I'm going to check and see if I can continue factoring, which in this case I can. So what two numbers multiply to give us -12 and add to give us 4? Well, in this case, those two numbers are 6 and -2. And since there's no lead coefficient in front of this b squared here, I can just write my new factors as b plus 6 and b minus 2. And I still have -b up front as my greatest common factor, and it is equal to 0. To finish off the problem, I just need to set each factor equal to 0 and solve for each variable. Now notice in this example, because my greatest common factor had b and a variable, I had to set it equal to 0. However, if your greatest common factor didn't have a variable in it, you would not have to set it equal to 0, as there would be no variable to solve for. Now, when we solve for each of these variables, we get 3 solutions. Now notice, we have 3 solutions, and our initial highest exponent, or degree of the function, was 3, and that highest exponent should tell you how many solutions you should have, and that's how you know you didn't miss anything. Now let's consider the problem on the right, and since it is already equal to 0, we can just begin by seeing if it's factorable. Since it is 4 terms, I can try factor by grouping. So the first 2 terms would have 16x squared in common and would have x minus 2 as leftover. Since the second group starts with a negative, I'm going to factor out the negative, and there's nothing else in common that the 2 terms have besides a 1, so I have a -1, x minus 2 since I factored out a negative. That was the first part of factoring by grouping. Now the new greatest common factor is x minus 2, and my leftovers are 16x squared minus 1. Hopefully you're noticing that 16x squared minus 1 is a difference of perfect squares. So we can factor that to give us 4x minus 1 and 4x plus 1, and we still have x minus 2 at the beginning. Notice my degree that I started out with was 3, and I have 3 factors here, so I know that I can set each of these factors equal to 0 and solve for x. So my first solution is x equals 2. Then for the next factor, I add 1, and I get 4x equals 1. Divide by 4, and I get x equals 1/4. And my last factor, subtract 1 on both sides, and I get 4x equals -1. divide by 4, and I get x equals negative 1/4. And that is all we need to do. And remember, we could have checked these factors by graphing these functions and seeing where the x-intercepts are and if they're the same values as we just got here. Different problem. However, what do we do if we're given a function that is a quadratic function, but it cannot be factored? Well, first, make sure it is written in this format. Notice that my quadratic function must equal to 0. And once that's the case, you can apply the quadratic formula, which is x equals negative b plus or minus square root of b squared minus 4ac over 2a. Now I want you to notice that the formula has a plus or minus. Since this degree is 2, we should have two solutions. And the way we get our two solutions in the quadratic formula is by doing this formula once with plus and this formula once with the minus. Now let's practice. We're going to consider the following two examples. Now, you can always try to factor, which I'll give you a hint, one of them is factorable, but any quadratic equation, you could always use the quadratic formula to solve. So we're going to just practice that in this case. So let's look at this first example. We have my a is 4, my b is 4, and my c is negative 3. And I'm going to plug those numbers into my quadratic formula. Now, a very important hint that I suggest is whenever you replace one of those variables with a coefficient or constant from your equation, is to put them in parentheses. That has helped many students not to make, and teachers, not to make silly mistakes in your simplifying with the quadratic formula. So let's go ahead and plug in. We have x equals negative 4 for b plus or minus square root of b, which is 4 squared, minus 4 times a, which is 4, times c, which is negative 3. All of this divided by 2 times 4. Now this gives us x equals negative 4 plus or minus square root of 64 over 8. Now, I want you to notice that the number we have under the square root is a positive number. So when we have that b squared minus 4ac is positive, then we know we have two real solutions. And it doesn't matter if it's a perfect square like 64 is, as long as it's positive, we can conclude that we're going to have two real solutions. So one easy way you can check if you're going to have two real or imaginary solutions is by simply calculating b squared minus 4ac, and if it's greater than 0 or really equal to 0, since square root of 0 would just give us 0, we would have two real solutions. Versus when we have b squared minus 4ac is a negative number, so less than 0, that would give us imaginary solutions because we cannot have a negative under the square root. In fact, when you have a negative under the square root, that is an imaginary number. But let's finish this first example. Hopefully you know that square root of 64 is just 8, so we have negative 4 plus or minus 8 over 8. Now remember when I said that this plus or minus just means we have two different equations. So we have x equals negative 4 plus 8 over 8 and negative x equals negative 4 minus 8 over 8. And we simplify the first fraction and we get positive 4 over 8, which is 1/2. And the second fraction is negative 12 over 8, which is just negative 3/2. So we have two solutions like any quadratic equation, unless it's the same solution twice, and we have 1/2 and negative 3/2. Now let's consider another example, and this one we should get imaginary solutions. So let's plug in. We have x equals negative, my b is negative 12. So as you can see, it can already help us to have parentheses since we're dealing with two negatives here. Then we have plus or minus square root of b squared, which is negative 12 squared, minus 4 times a, which is 4, times c, which is 13, all of it divided by 2 times 4. Now we're simplifying this and we get 12 plus or minus square root of negative 64 over 8. And again, that's going to be an imaginary number. So we get 12 plus or minus 8i, because again, negative means imaginary number, over 8. Now at this point, I could split up my fraction with one with plus, one with minus, the same as we did with the other example. However, since I have an I there, I know I won't be able to combine these numbers into just one number like I did before. So I'm just going to simplify this fraction as is. So there's two ways we can go about simplifying this fraction from here forward. One way would be to find what's the greatest factor that all three of those numbers divide by. So in this case, it would be 4, and I would have x equals 3 plus or minus 2i over 2. So again, all of these were divisible by 4. Another way I could have written this is I can divide 12 by 8, so that would be 3 halves plus or minus 8 divided by 8 is 1i. So I can either keep it as one big fraction or separate each term on the top and divide it by the bottom. Both are correct ways of simplifying. The important part is that you simplify whatever we had above. Now you try this problem. What should we do first? We should make it equal to 0. Ideally, once you make it equal to 0, you would check if it's factorable. In this case, it's not, so I'm going to go straight to the quadratic formula. And I have x equals negative b, which is 4, plus or minus square root of b squared, which again is 4 squared, minus 4 times a, which is 9, c, which is negative 16, over 2 times a, which is 9. This simplifies to negative 4 plus or minus square root of 592 over 18. Now I should get two real solutions in this case. However, 592 is not a perfect square, but I still need to simplify 592. And 592, the biggest perfect square in 592 is 16. 16 times 37 gives us 592, and square root of 16 is 4, square root of 37. So then I can rewrite this as x equals negative 4 plus or minus 4 square root of 37 over 18. And again, I'm going to show you the two ways we can simplify this. We can either find a number that all three of these are divisible by, so that would be x equals, they are all divisible by 2, so I could say x equals negative 2 plus or minus 2 square root of 37 over 9, or I could have written it as x equals negative 4 over 18 plus or minus 4 over 18 square root of 37, and simplified each of those fractions, which gives us negative 2 over 9 plus or minus 2 over 9 square root of 27. Both of these formats would be acceptable. Now, sometimes you might have to use a combination of factoring and quadratic formula. So considering this example we've been given, I can see that there's a greatest common factor, so I'm going to factor it out. So I have 2w cubed plus 8 equals 0. Now I can also see that w cubed plus 8 is a sum of perfect cubes, so I'm going to use crummy sops to factor it. So I have 2, and then crummy is cube root of the first term, so that's w plus, because I keep the same side, crummy again is cube root of 8, which is 2, and then sops is square of the first term, which is going to be w squared. Ops OP is opposite product, so instead of, I'm going to use the opposite of positive is negative, and the product of W times 2 is 2W, and then crummy sops, the S is the square of the second term, which was 2, so the square root of 2 is positive 4, and I have this equal to 0. Now, I can set each of these factors, since we've learned that this last parentheses is not factorable any further, we can set each of these factors equal to 0. Now, since this greatest common factor is only a 2, I do not need to set it equal to 0 because 2 can never be equal to 0. So I only have to set each parentheses equal to 0 by itself. So I have W plus 2 equals to 0. And I also have W squared minus 2W plus 4 equal to 0. Now the first term is very easy to solve. I just subtract 2 and I get W equals negative 2. Since the second factor is quadratic and it's not factorable, I'm left with using the quadratic formula. So I have W equals negative 2 plus or minus square root of negative 2 squared minus 4 times 1 times 4, all divided by 2 times 1. And be careful that your fraction extends over all of that. So now we simplify and we have W equals 2 plus or minus square root of negative 4 over 2. Now that means I'm going to have imaginary numbers. So if I was to graph this to check, I would only see W negative 2. That's the only one I would see as a solution or an x-intercept. So both of these are going to be imaginary solutions, but I'm still going to have 3 answers to my original problem. So now I'm going to simplify this fraction and I'm going to get 2 plus or minus 2i over 2. And all 3 of those numbers divide by 2. So I'm just left with 1 plus or minus I. So again, remember, these are 2 solutions, 1 plus I and 1 minus I. And that is it. Now let's go practice solving with factoring and quadratic formula.